Okay, we are going to talk about the unit circle today. The first thing you need to know is probably why it's called the unit circle. It is called the unit circle because it is centered at the center of the graph, so the origin of the graph. And has a radius of exactly 1 unit. So in other words, right here on the unit circle, on the graph, the coordinates would be over 1 unit and up 0. So the radius is 1. Or right here on the graph, the coordinates would be over 0 units and up 1. Right here, we would be going back 1 unit and up 0 units. And right here, we would be going over 0 units and down 1 unit. So the radius never stretches further out than 1 unit anywhere on the circle. There are 2 ways to measure around the unit circle in math that we'll use. One way is to measure in degrees, which we know we can do using a protractor, and it goes 360 degrees around the circle. Right, and when they are measuring around the circle using degrees, we always start right here, and we go in this direction to measure in positive degrees. So you go counterclockwise for positive, just like when we were doing rotation, we measured counterclockwise degrees to get positive. Right, and so right here at this point is 0 degrees. But it's also 360 degrees because when we come all the way back around. So right here, I'll just draw an arrow. This is 0 degrees or 360 degrees. And then I can measure this far around the circle, 1/4 of the way. And if you measure with your protractor, you'll see that this spot is 90 degrees. Okay, and then we get a little bit further. Right here is 180 degrees. And then another 1/4 of the circle, and we are at 270 degrees. And then back at the beginning, we are at 360. The other way that you can measure around the circle is, well, there's another way, another unit type of measurement that you can use. But if we go the other direction, again, just like with rotations, we go clockwise, it's a negative degree measurement. So for example, I still start here at 0, but when I get to here, instead of being 270, we are at negative 90 degrees, because I've gone 1/4 of the way around the circle in the negative direction. Or if I'm measuring in the negative direction, this is positive 180, but it's also negative 180 degrees. And then I can go up further and get to here, and it's positive 90, but it's also negative 270 degrees. And then back at the beginning, I would be at negative 360 degrees, or 0, or positive 360. So again, measuring counterclockwise around the unit circle is positive, and measuring clockwise around the unit circle is negative. And again, it is called the unit circle because the radius is exactly 1 unit. There is a second way to measure around the unit circle in either direction, and that is called radians. And a radian is the length of the radius stretched around the circle. So I'll show you what I mean in just a second, but let's write it down. So again, the length of the radius stretched around the unit circle. So for example, if I were to take a piece of string and cut it to exactly the length of the radius, which is 1 unit, so I cut that string to exactly the length of the radius, like so. A radian is when we take that measurement and stretch it along the edge of the circle. So 1 radian, I'm lining it up as best I can, it's not going to be perfect, but 1 radian would be right here. This is the length of 1 radian. Okay, and then I'm going to continue. I'm going to stretch it around the rest of the circle to see how many times it goes. So here is about 2 radians. About 3, so just over 3 is half the circle. We will keep going. 4 radians. 5 radians. And 6 is right here, and then we have some change. So again, we counted 1, 2, 3, 4, 5, 6, with a little bit of extra in here. And if we were to figure out exactly how much extra that was, we would find that it was about 6.28 radians around the circle. Or another way of thinking about that is 2 pi radians. And it's more common in math and trigonometry that we will talk about radians in terms of pi, because pi is a more exact term. When we say 6.28, we are rounding that number. And just like pi, if you multiply pi by 2, it's going to still go on forever. So this is right here is even a rounded decimal. So when we say 6.28 radians, we're rounding it. But if we say 2 pi, we are including all the digits that go on forever. And this is actually where pi comes from, is because exactly halfway around the circle, so this is a whole circle, or 360 degrees, but exactly halfway around the circle is pi radians, which is about 3.14. So what they were, how it was created was that they discovered that the radius went around the edge of the circle exactly 3.14 and so on forever times, and so they decided to call pi 3.14. They thought it would be easier to have this to represent it instead of writing all of these digits. And just as a side note, a lot of mathematicians are actually proposing a new representation of how many times the radius goes around the circle, and it is called tau, and it looks like that. And tau is equal to about 6.28. So the reason that they're proposing this instead is because this represents how many times the radius goes around the entire circle instead of just being half of the circle. So a lot of mathematicians think that it makes more sense to measure around the whole circle instead of just half at a time. But we won't use tau in this class. You might use it in math classes in future, like in college and stuff. All right, so we have talked about measuring around the circle being 360 degrees. measuring around in radians, which is the radius stretched around the edge, which happens about 6.28 times. And now we're going to talk about how to go back and forth between degrees and radians. And to do that, I am going to draw a new circle because we are getting very filled up. So a unit circle may appear bigger or smaller, but that depends on the size of the unit, because remember that a unit is kind of a variable term. It could be a really big unit or a really small unit, but we just call it 1 unit. So this again is our unit circle, and we're going to talk about measuring around it in 2 different ways. So like we've said, one way is in degrees, and we go from 0 to 360. So I could have 0 degrees right here and 360. And as a side note, I looked up why there are 360 degrees in a circle, and there's a lot of different reasons actually. Some people think that it's because the sun moves about 1 degree a day, which is why there are 365 days in a year. So they think that maybe this number was chosen because of the number of days in a year. Another theory is that the number 360 is really, really, really divisible, which what I mean by that is that it's divisible by 24 different numbers. So it can be broken into lots of even pieces, as opposed to the number 365, which is not as divisible. So that's just a side note why they chose 360. So if we were measuring around the circle, I could take my protractor and measure part way around the circle. Let's say I wanted to go 60 degrees. And I could mark this point right here and say that it is 60 degrees. It's a little bit harder to decide how many radians that is. So what we're going to talk about is how to convert back and forth between degrees and radians. So the way that we do that is by figuring out how many radians 1 degree is. So I know, for starters, that 360 degrees is equal to 2 pi radians. Because remember right here, we measured around and it was 2 pi radians, or 360 degrees. So to figure out how much 1 degree is equal to, I'm going to divide this by 360. But to keep the equation balanced, I need to do that to both sides. If I divide this here, I get 1 degree on this side. And if I simplify this fraction here, I end up with pi over 180. So 1 degree is equal to pi over 180 radians, which is a really small amount of radians. If we take pi and divide it by 180 degrees, or by 180, it's just 0.17 about radians. So it's a really small amount of radians, just like 1 degree is really small. So if I know that 1 degree is equal to pi over 180 radians, that means that I can pretty easily now figure out how much 60 degrees is. Because I can do, I can multiply both sides by 60, because I know 1 degree is right here, so I want to multiply this by 60, and again do the same thing to both sides. And I'm doing this because now I'm going to have 60 degrees on this side, which on this side I'll have 60 pi over 180. So I know that 60 degrees is equal to this. But I can tell by looking at these 2 numbers that I will be able to simplify this fraction. So let's say I divide both by 10 to start. I get 60 degrees is equal to 6 pi over 18, which it looks to me like I can reduce that more. I can divide both of those by 6 now. So I'm just simplifying the fraction. and I end up with 60 degrees being equal to pi over 3. So 60 degrees is the same as pi over 3 radians. And pi over 3 is, oops, you can see just over 1 radian, so about 1.047 radians around the circle. So if I took the radius 1.047 times, I would end up with 60 degrees. Let's try another one. Let's say I want to measure 135 degrees around the circle. And I want to know how many radians that is. So I'm going to do the same thing. I want to know how much this is. So I know that 1 degree is equal to pi over 180 radians. So I'm going to multiply both of these things by 135 to find out how much 135 degrees is equal to. So 135 degrees on this side is equal to 135 pi over 180. And I'm going to reduce the fraction again. I will start by dividing both by 5 to see what I get. And that is 27 on top. Oops. I'm going to write it over here because I'm running out of space. So 135 is equal to 27 pi on top. And on the bottom, we have 20. Oh, my brain stopped working for a minute. Sorry, 36. I don't know what happened. All right, and then it looks like I can divide more, so let's say I divide both of them by 9 now. And I get 3 pi over 4. So if you see something that divides into these numbers more quickly to simplify the fraction, you can do that, or you can do it by bits and pieces like I have. So now I know it doesn't look like 3 and 4 can be reduced anymore. So 135 degrees is equal to 3 pi over 4 radians. All right, and I could also do this same thing in the negative direction. If I measured negative 60 degrees around my circle, when I am multiplying up here, I would just multiply by negative 60, and I would end up with the same answer. So if this is negative 60 degrees, it would also be negative pi over 3 radians. So you can measure, just like with degrees, you can measure with radians in the negative direction. It would just be clockwise. To convert from radians to degrees is a similar idea. I want to know exactly how many degrees are in just 1 radian. So once again, I know that 360 degrees is equal to 2 pi. And this is 2 pi radians here, but I want to turn it into 1 radian, so I'm going to divide it by itself. And this cancels out and turns into just 1 radian. And on the other side, I have 360 over 2 pi, which I can reduce again if I divide both of these things by 2. Then I end up with 180 over pi. So 180 over pi degrees is equal to 1 radian. So then I'm going to do a similar thing. Let's say that I have, I'm going to slide this over and write on the back here. Let's say that I have a spot on the circle. For up here, for example, I know that this is pi over 2 because halfway around the circle is pi, but a quarter of the way around the circle then would be pi divided by 2 because it's half of the halfway. So I want to know how many degrees that is. So I'm going to take pi over 2, and I know that 1 radian is equal to exactly 180 over pi. So I'm going to figure out how many pi over 2 radians is equal to. So just like last time, I'm going to multiply both sides by what I want to know. So if I have 180 over pi times pi over 2 over here is equal to pi over 2 radians, I end up with 180 pi on top and 2 times pi on the bottom. So I know if I have the same thing on top and bottom, these cancel out. So now I have 180 over 2, which if I divide, I end up with 90 degrees equals pi over 2 radians. So pi over 2 right here is equal to 90 degrees. Or let's say I had, I don't know, pi over 6 radians right here. And I want to know how many degrees that is. So I know again that 1 radian is equal to pi over 180 degrees. So I'm going to multiply both sides by pi over 6 because that's what I'm trying to find. I want to know how many degrees pi over 6 radians is. So I end up with pi over 6 radians on this side, and that is equal to 180 pi over 6 pi radians. Or I'm sorry, degrees. And once again, my pi cancels out. You could cancel that out right away if you see that it's going to be on both top and bottom. And I have 180 over 6 left, which 180 divided by 6 is 30 degrees. So pi over 6 is the same as 30 degrees. And I could do this with any degree measurement on the circle. The ones you're going to be doing on the worksheet are pretty friendly measurements, but some of them might be a little bit more complicated in the future. All right, I will post a picture of these notes on the Google Classroom for you to look at, and you can email me any questions.